I hope you are no longer confused when I choose between Markdown and Code. Okay, Markdown creates these beautiful headings. If I put one hash, I get a big heading. Okay, so data structures. What are basically data structures? Now, a data structure, this is a way of organizing and storing data. Storing data so that it can be used. It can be used efficiently. Efficiently. What am I typing? Okay. So I don't need to comment. So that's what basically data structures are. And it's a way of organizing information and storing data so it can be used efficiently. Now, what are some of the data structures that we have? Okay, some of the data structures that we have already seen lists. Okay, we're looking at lists, and lists, they in themselves, they are ordered. Okay, we shall see what ordered actually means. They are changeable, meaning also we said in the last class what we can say it is mutable. You will hear that word a lot. Okay, so where we can we use lists, for example. For example, we can, when you are trying to shop on Jumia or Amazon or whatever, your items might be embedded in a shopping list or taking user input. Okay, collecting user input. So the second one is what we call a tuple. So what is a tuple? A tuple is also ordered. Okay, so this ordered means that data type, whenever you print out, the information will always appear the same. Okay, and ordered means they can be also, since the order is defined, it means they can be accessed using indexes, like how we saw indexes in the previous session. So ordered tuples, they are ordered, but they are immutable. Okay, so where can we store data that is maybe in tuples? Or if you're using geospatial data, you can store coordinates because you do not want them to change. Coordinates, or maybe days of the week. You're creating a tuple with days of the week, so you do not need to change it because what has changed about Monday? Nothing really. So we can have them like that. So we have sets. Okay, sets. Now these ones are unordered. Okay, so these ones are unordered, and they actually allow not duplicates. These two allow duplicates. Okay, so let me put another. They allow duplicates. These can also allow duplicates. Okay, but with sets, you are not going to play around and put a duplicate. It will be ignored. So where can we store, for example, sets? Can use it in like user IDs. Okay, so for example, let's say we created a system, student system, and we have two students of the same name. Let's say, for example, we have Aine Provia, and there are two, but they are two different people, despite having the same name. You can have them have different IDs in the system. So you can use a set because a set will not allow duplicates. So we can have dictionaries. So with dictionaries, these are what we call key value pairs. They allow key value pairs. Okay, key value pairs, and we shall see what is entailed in that, and we shall look at it in detail when we get to it. So we can store data, for example, like a name. Okay, we can, for example, but let me just leave it at that, and let's get right into lists. So these data structures, okay, let me get to lists here. As we said, lists themselves, they are ordered. They are changeable or mutable, and they store collections of data, which can be of different types, first of all. And now we said in the previous class, we can have lists be defined by square brackets. So for example, let's say let's try to create a list. So when you're creating a list, we have two ways of creating a list. We can create a list by saying, maybe, let me just say maybe list one. List one, it can be equal to, and I use my square brackets to define the list. So 1, 2, 3, 4, 5. Okay. So we say that list can store any kind of data type. So I can say maybe list 2 equal to, and I put maybe strings. Okay. I can put my strings in there. C, I can say D, right? So, or I can create a list, list 3 with mixed data types. I can say I can have 1, I can have an A, I can have float 2.5 there. I can have a true with a capital T. Okay. So this is a Boolean, this is a float, this is a string, this is an integer. So we are having all this, and when we try to actually print out what is in list 3, okay, we get the list printed out, right? So now these lists actually can also be created using a list constructor. So I can say, for example, my names. Let me just first comment using a list constructor to create a list. This is the second method. I can say maybe names is equal to list. Okay. So when I say names is equal to list, that that is what we basically call a list constructor. So now when we are using these kind of list constructors, it is very key to note that you have to first say that maybe I can first create I can say names for is equal to list, and when I print out names, I actually of course have an empty list. Okay, but I have already said that I want a list of names. So what can happen? I can say store names in there, and I say start with mine. Say maybe Peter. I can say maybe John. And when I print out names, I should have a list full of those names. Now I want you to note this double curly. Those are they curly brackets? Those curved brackets. They are 2. So let us go back. We can either create it by directly assigning a variable to whatever is in these square brackets, or we can use a list constructor to assign those lists. Okay, I want you to stay with me. So now let us have an example. So let's say we have a shopping cart, right? A shopping cart, right? So we're trying to shop maybe online, and we are having a shopping cart. So a shopping cart, let's add our products there. And maybe you have said by not bought a notebook or notebooks. Comma, I have bought maybe Hisense TV, or I have tried to buy a phone. Okay, this is my shopping cart. And in most cases, you find people structure them like this. Okay, so you can structure them like this. This is all the same thing. Just make sure that it does not confuse you. But in most cases, you will likely to find it structured like this. But for maybe simplicity, let us just have it in this form so that it is easier to read. So if we try to print out a shopping cart, right? That is a shopping cart. Now we can actually access items within a list. Okay, so we can say that they are ordered. First of all, okay, they are ordered, they are changeable, and they allow duplicates. So which means I can have another Hisense TV in here. Make it that the exact one. We can have another Hisense TV in here, and them being ordered means they carry, each of these is represented by, they contain can be accessed using an index. So this is position 0, this is 1, 2, and 3. So we can try to see what exactly is position number 2, okay, by of course using shopping cart. And remember how we were doing our indexing using strings. It is phone 0, 1, and 2. So what is that position? Maybe I want to see what is that position 0. Position 0, it is notebooks. So can I try to access all these items using slicing? Do we all remember slicing? For most people, they got confused. Others understood it, but let's keep it simple. I can say shopping, or maybe I can say print shopping cart. Shopping cart. I can say 0, and remember what this does. Who can unmute their mic and tell me what this will bring out? Members who can unmute.
It will print out the notebook.
It will print out the
no, the entire. Yes, it will print out
the entire list.
Shopping cart.
Yes, the entire shopping cart. So that is what that means. Okay. So you need to understand this part of splicing. You need to really get used to it. This is one of the concepts that you'll never do away with. So I can also say, maybe I want to print out shopping cart from 1 to 3. Okay. And yeah, I will have 1, 2, 3. So this is 0, 1. This is 0, 1, 2, 3. So remember, the last item is not printed. So we are going to have the start and the stop, which is the 1 and the 2. So printing out Hisense and phone. So the other thing that we can do with these shopping carts is we can actually reassign shopping cart. We can reassign items within the shopping cart. So you remember when I said in strings, my name is equal to, I can say John. If I try to say that my name, I want to change maybe the letter at the index of 1 into an E, okay? And I say my name at the index of 1, change it to an E, right? And then to print out my name. Okay. Who remembers what we said would happen when we try to reassign, when we try to change an item in a string using an index? Who remembers what we said? Anyone remembers? So we shall basically get an error because we say that strings are immutable. They do not change, okay? So if you wanted to change this John into maybe John with an E, that would be a Jane something, you would have to now redefine it again, okay? You now have to redefine it and put the E there, okay? So now this, of course, you do not, we cannot accept that. So it is immutable, but with strings, with sets, it is a different thing. I can get a set, for example. I can say, maybe I do not want the phone, but I want a tablet. So I can say shopping cart, okay, at which select an index. Let's get our shopping cart again here so that we do not keep scrolling back and forth. Okay. So shopping cart, you can say maybe you can change the font to a tablet. This is 0, 1, and this is 2. So at index number 2, I reassign it to a tablet. Okay. And when I print out shopping cart, when I try to print out shopping cart, I should have that item at index number 2 changed. Okay. So this is the concept of mutability. So we can have these items changed. All right. So now I want us to come to and check for the length of lists. For example, if I tried to maybe say name is equal to any, all right? So even with strings, we can check, we can use the length function, okay? And check for the length of name. This is how password checkers know the length of your password. So they check, they're like, okay, is it 6 characters or more? Is it 8 characters or more? So when you come in and use the length function on a string, it will give you the length of that string. Now, likewise, we can get a length of a string or of a set, of a list, sorry, not a set. I can get the length of shopping cart, and it will tell me that I actually have 4 items. This is 1, 2, 3, 4. Okay, don't confuse it with indexing, which starts at 0. When you're actually just counting items, it is basically 4. But when you're indexing them, they start from position 0. So now we can check for the length of sets. And let us remember we used a type function some time back. We can check for the type of shopping cart, and we shall see, are we on the right track, or is it a set? So if we check for the type to show us that actually this is of a data type list, right? So I was showing you that we can create a string, a list, using a list constructor, and we can use it by just directly assigning it using those square brackets. Now we can check if actually an item is within a list. Let's check for our, let's use another, let's maybe fruits. Fruits will be equal to, maybe we have apple, we have mango, we have banana. So when you do something like that, we can actually check that if I want to check if maybe mango is in this list, I'm going to use a concept that we shall expound more on in the next class, which are if functions, but we can actually check. So we say if, okay, if is a reserved word, it's a keyword, so you cannot use if to assign it to a variable. So we can say if apple, and we remember that we also saw a keyword sometime back called in fruits, okay? So we are literally saying if apple is in the list fruits, okay, press enter. Now you'll note that the cursor comes here, it does not go back to the start, okay? And if yours goes back to the start, press a tab button to bring it. Why today's daily developer note, I brought in the concept of indentation of code. So Python is sensitive when it comes to indenting. So for example, even if I just said, let me first copy, cut this line of code, and I said fruits starts from here, and I'm going to print fruits. It works, but when you are in your VS Code, it might not actually work. So, but let us continue with what I was trying to say, that you have to want to indent your code. Let me bring it, let me say here that if apple is in fruits, maybe you can print yes, apple. Yes, it is in fruits. So when I run that code, it should give me yes, it is in fruits, because apple is actually in fruits. But let me put my print statement here. So this is what I was trying to say, that this is an indentation error. It is saying that expected an indented block after if statement. So you have to indent your code to show that this line of code is actually under this. It is following this. It is dependent on that, okay? Without this line of code, this line should not work, all right? So that is why the indentation error occurs. So you have to indent your code properly whenever you are coding in Python. So now we shall talk more about if statements in the next class. Here I just wanted to show you how you can actually check if an item is within a list. We saw that we can actually change items within a list. Let's continue using our fruits. We saw that we can actually reassign and say maybe at position 1, I want to change the mango to jackfruit, and it worked. But what if I wanted, let me make this list a little bit longer.
Josh,
Yes.
may I ask a question?
Mm-hmm.
Isn't saying print yes, it is in fruits, like making it obvious for the code to like run an obvious answer? Isn't it supposed to like, I don't know how
let us
to
change.
say it.
Let us change and say grapes. Okay, we do not have grapes in there, isn't it?
Sure.
If I run it, it's not going to bring anything. Does that answer your question?
Yeah.
So yes, that is what happens. So I didn't want to put an else statement here, but we can have an else statement which says if in case apple is not in fruits, print out yes, it is not in fruits. But we shall look at that concept more in the next class, which is on Monday. So let us.
I get it. I get the whole concept.
Yeah. So let us put. Let's make our list a little bit longer. Which other fruits are there? We can have maybe grapes. I love grapes. So we can actually change items based on an index. Okay. So I can say fruits from index 1 index 3. Okay, from index 1 to index 3, assign it to another list. Okay, so we have to make sure that from index 1 to index 3, we have this is 0, this is 1, 2. So this is 3. 3 is ignored. So we need to put 2 items in here. Which other fruits exist, guys? Which other fruits? Which other fruits? Let's say maybe a pear. I need to another fruit, which is like an orange. Okay. So when we do that, and we print out fruits, we should be getting an orange and a pear in those positions. So we see how our slicing is actually useful. So we can just define that one, start from here, stop here, but replace it with a pear and an orange. Make it capital. So we can use our slices to change items within a list. But we can also insert using an insert method. So we saw that when you say, for example, fruits is equal to, fruits at maybe index 1, and you maybe change it to, I've run out of fruits in my head, so let me just put another fruit. So when I say another fruit and I print out fruits, I will get another fruit at index 1. But we also have another way of using an insert method, okay? We remember talking about methods. We said methods are always associated with an object, okay? Everything in programming, in Python, everything is considered an object. A string is an object, a list is an object, a variable is an object. Everything is an object. And if we can have a function associated with that object, in other words, if that function cannot work without that object, it is called a method. Don't get confused, because we are seeing the print. The print will work alone. It does not need to be appended onto some other object. But if we can have something like fruits dot insert, okay? Fruits dot insert. So a method always has those double, those cap brackets, and we can say insert, but the insert method works like this. It has to have an index, first of all. It has to have an index, and then we have to put in the variable, or you can call it the item within that list. So we need to define which position. We can say position 3, comma, and we say maybe third fruit, okay? And when we print out our list of fruits, we should have third fruit somewhere. So this is an insert method, okay? Now, we also have another way of inserting items within the list, and that is what we call appending. Now, appending just does not need you to add an index. So I can say fruits dot append, okay? Append, okay? So fruits dot append, and I will just add another fruit. Let me say lemon. So if I say fruits dot append lemon, I want you to see what happens. What
Josh.
Yes.
I have a question. I have something that has appeared in my when on fruits 1, when I print that list, That's another fruit appears in curly brackets in the list.
You're saying in fruits here,
Yeah.
fruits, and
Okay,
then
okay.
you
I
put
think
index 1.
I've seen my I think I've seen my mistake. It's okay, we can move.
Okay. So
Sure.
I want you to keep noting that memory keeps updating this list. Okay, it keeps updating this list. And if I say that fruits.append lemon, I will have a lemon at the end of that list. The append function, the append method will add it at the end. The insert, you'll have to define the position where you want it. Okay. You can also use this where you use the index, but you're dealing with replacing. Let us continue. We can remove a list item. Removing a list item. So if we remove a list item, we can say fruits dot remove. Okay, fruits dot remove, and we can select. Maybe we can remove the orange from this list. Okay, we can remove the orange from that list, and when we print, let me just copy this and paste it here. So when you print out fruits, it is going to remove orange from that list. We also have another method, okay, of removing that using what they call the pop, using the dot pop, okay. That's also another method. But with this one, we need to define the index where we are to remove that. So we say dot pop, and I need to put in the position, okay. I need to put in the position. This is 0, this is 1, this is 2. So the new list should not have third fruit in it. So when I print out roots, I should not have third fruit because it is in position 2. We have also the delete keyword. Okay, we have a delete keyword, which is I can say fruits. Okay, or I can just say deal, which is delete. I say fruits, and I want maybe index number 3. So index number 3, this is 0, 1, 2, 3. So it should remove pineapple. So if I print out roots, I should get pineapple removed. We can also clear this list using we can use the clear function, the clear method. Okay, so I can say list, fruits dot clear, and when I say fruits dot clear, I will have cleared my whole list. Okay.
Just trying too fast.
I'm too fast. Actually, I think the way why I'm too fast is because I'm copying and pasting some code that I had written before. So I'm not typing some of the code. Like for example, this I just keep pasting. It appears like I'm too fast, but let me try to slow down. So I said pop. The pop method removes an item from my list, but you have to define the position. Tell it the index. You can also use this using the delete keyword. Okay, you can use the delete keyword. You can clear the list using the clear method. And if I try to print it out, it's going to show me that it is now an empty list.
Josh, I have a question.
Yes.
I didn't notice this, but there is a time we put fruits insert 3, then comma and a third fruit.
This?
Yes, on my
Okay.
end, it inserted third fruit twice.
Did you have third fruit somewhere already?
Before, no.
Okay, you first paste your
Robert.
code within your
Hello?
it's a screenshot within the group, and I look at it. I
Hello?
see what is happening. Yes.
Hello?
Yes, hello. Hello, hello. Anyway. Okay. So now we can sort these lists. So for example, I can say the list containing my numbers, maybe my nums, is equal to 45, 78, 32, 566, 1, 2, 3, 4. Okay. So we can actually sort these lists in order, ascending order. Okay. So I can say my numbers.
Josh.
Yes.
Hello.
Yes, yes.
Forgive me for taking you back. I tried something after the clear. I tried to insert and it printed nothing.
Yes, because
in that case, do I have
yes,
to define again the fruits
you
list
have
again?
you have cleared.
Yeah, after clear, I just tried out of curiosity, did an insert function.
Insert, remember the way it works? It puts,
yes,
how to select an index, but now the list is already empty, so there is nothing there. There's no position
okay.
You're trying to define. Okay.
Okay.
Yes, there's no position you're trying to define. That's why it prints nothing. It's trying to find that position, but it can't find it. So I want us to rush through this.
I just posted in the group.
In the group. So you have 3 third fruit to put third fruit. That fruits that insert 3 third fruit. Apple fruit, third fruit, third fruit. Did you run the cell twice?
I have no idea.
You might have run that cell twice.
Okay.
So you go back to that cell and run it again once.
Would that be the third time? Okay, let me see again running.
Oh, excuse me, let me first silence some phone that is making noise here. Okay. I'm back. Are we?
Now my issue is even worse now. How do you rerun? Because when I run, it's now generating third fruit only. I run again, it's again third fruit only. Like it does not come as a list, as a whole list.
Okay. So now what you do is let us just continue. Let us just continue. We're left with 27 minutes. Yet we shall sort that after. You just need to restart your kernel, and I'll show you how to restart your kernel. Okay. So because we have to run through sets, I need to run through tuples, need to run through dictionaries. We might not be able to cover dictionaries because of time. So now I said we can sort these things. So I can use a dot sort. I can use a dot sort method. So these methods are actually I'm just trying to show you that I can't show you all, but we have, as I said, that we can try to go to W3 schools and wait, what am I printing? So I'm to print my lamps. So you see that it sorts it in ascending order. And if we had items like names, and we can list, I say Kate, I say June, I say, I don't know who Zam is, but, and we say that we want names.sort, okay? Names.sort, and then I come and print out, if I come and print out names, you see that it will sort these things in, wait, names.sort and, wait, names.sort, Zam, John, Kate. Oh, it has reversed them. But in a descending order, we need to put names.sort, say reverse. If we set true, I want you to see what will happen. Okay. If we say reverse is equal to true, it is going to make it in that kind of order, in the alphabetical order. But if we do not do that, it's going to start from Zam going downwards. So I wanted to show you something that will be confusing you.
Josh, I didn't see the alphabetical order that's changed.
Okay, so you see our names. We have Kate, we have John, we have Zam.
Yes.
Names.sort prints out the list from Zam, John, Kate. Now, someone was saying when you run this code, they do not see the order, the way alphabetically it is. So we say, let's say Kate, John, let's make this J capital and Zam. So if we print it out that way, it comes in the alphabetical order that we know. Okay?
Yes,
if we make it a small j, this is because Python is using a Unicode kind of format. And in Unicode, this Z comes before a small j. So let's say Unicode. I think something like that. Where Unicode characters. Where are my Unicode characters? But anyway, encodings, where are these Unicodes? Where are these Unicodes? Let me not confuse you, but let me just describe it. That in Unicode, we have A, B, C, D, E, F, G, okay? And then we shall have an A, B, C, D, E, F, G. You get? So in Unicode, this capital C comes before the small c. So if you have a list of items with 3 capital C's and you have a Z in the middle, and then you have small c's at the end, the Z will come before because the capital letters will come first in that arrangement. Are you getting the point?
Yes.
Yes. So in here, this capital A comes before the small a. This capital B comes before the small b. So if we had an item where I had maybe Bob, and then I had Bob, this Bob will come faster than this Bob. And if I had Dan, this Dan will come before this Bob because you see the order it follows. So the thing is just to convert it to a capital letter, and then you have it in the actual alphabetical order that you need. So, but if you have reverse is equal to true, you will convert it, the capital T. What's wrong with my keyboard? So it will start from the back to the front. Are we clear there?
Yes.
Yes. So now let me try to show you something small that would confuse you when you are working with
Josh.
Yes.
Okay, no, you can move, no problem. No problem. It's okay.
Okay.
It's okay.
So let us bring back our shopping cart. And our shopping cart, let's say, let me not use this kind of stacked format. Let me just use it. I have notebooks. I'm typing a little bit faster so that I save. Let me say I have sunglasses. Let me say, for example, I'm buying from Jumia and I have toys. Okay. So if I have toys and I have grapes. Okay. So let me say that is my shopping cart. Now, we said that we can have, let me do this. Let me say maybe, for example, I want to get a new cart. Okay. And new cart, I say it is equal to shopping cart. Stay with me. And if I print out new cart, I have, of course, this list, because I've said new cart is equal to shopping cart. But let me try to reassign an item. Let me also try to print out this shopping cart so that we see what is happening line by line. So you see that they are both identical because shopping cart is this. New cart is equal to shopping cart, which is okay. And when I print out new cart, it gives me the same items of the cart. And when I print out shopping cart, it of course gives me the original. But let me try to reassign a certain item. And I say new cart at index number 0. Okay. I want you to maybe change it to a keyboard. We all expect this item here to change to keyboard, isn't it? So when I run, you will notice that both the new cart and the old shopping cart have been updated. So this is something that I want to show you, that what you are doing is Python has already stored this shopping cart. You have said, I want a new cart, which is no problem, to equal to shopping cart. So here you are using what they call reference. So you have not copied this list so that you can use it, you can change it the way you want. What you have done is you have referenced it in memory, and it is going to change the original cart. What you can do to prevent, because in most cases you want to deal with a new list without affecting the old list. Okay, so what you can do is, let me just copy this code here, leave that there for reference. So I can say shopping cart is equal to that, and shopping cart Now let me change this, because in memory we already have shopping cart as this. Let me change this to maybe Jumia cart, all right? And I change this shopping to Jumia cart. I change this to Jumia cart. Now, what you can do is you can, when you want to copy this this list, just come and put a full colon. Now, when I run that, I have this new cart affected, but the old cart remains. So alternatively, you can use the .copy method. Okay, so I can come here and say .copy. All right, and I'll run that. The original Jumia cart will not be affected, but the new cut is what will be affected. So when you try to reassign, like how we are seeing that I can have name and then have to in strings we looked that if you have something like name, if you want to change it, you have to reassign it to another variable. Okay, but the string in itself is immutable. But don't forget that lists are fragile. They are mutable. They can be changed. So if you want to just create an actual copy of the first list, so that when you modify it, it does not affect the original list, you either use the .copy method or just come and put a full colon. Okay. So now that is what I had to show you on lists. And I want to show
Josh.
Yes.
Let's go back up slightly.
Up where?
Yes, there on shopping cart, new cart.
Yeah.
Yes.
Mm-hmm.
So when you print new carts, it adds the keyboard. Does it add the keyboard to the shopping cart?
Pardon? That does it add? Oh, so let me let me print this as new cart and print after new cart. I print out the Jumia cart. So
oh no, that keyboard
is replacing in index 0, which is notebook.
Okay.
Yes.
Okay.
But this change does not affect the original list. So what we are doing here, if you remember in slicing, I have said just take a slice of the entire list. Okay.
How come?
Yes.
So what you were demonstrating in the first instance was that, because if you printed shopping carts, the keyboard would still replace notebooks.
It would replace
right?
notebook, yes, in the first original
So what
list.
we are trying to do is adding keyboard without replacing notebooks, right?
Without replacing notebook in the original list. We don't want to affect the original list. We just want to create a copy of the original and do what? And play with it, basically, change it. So this happened to me a few years ago. I was delivering a project to a client and it had this bug and I didn't know that actually lists work like that. So I thought I would find it nice to bring it up so that in your projects, when you do not have something of that sort happening. So are we okay? So let me come to tuples. I want us to come to tuples. So get my markdown. Spend some time on lists because really lists are very, 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 very important. So what is a tuple? A tuple is also a collection of items, like how a list works, but it is ordered, okay, ordered and unchangeable, okay. So tuples, they are written with round brackets. We saw that. Let me just say this is 1.1. This is 0.2. So they are written with round brackets. We saw that lists have square brackets. So we saw that these ones are written with round brackets, okay, with the round brackets. And they are basically, once you have created, you cannot change its values. Once created, you cannot change its values directly, okay? Change values directly. So also we saw this is what we call immutable. Okay, so you should remember that tuples are immutable. Written. So now let's look at a tuple. So I can say, for example, my tuple. Okay. Oh, we cannot have hyphens within a variable name. So my tuple is equal to, it is simple. I can just say maybe I have gun, I have TV, and I have maybe Vaseline, right? So I've already defined a tuple, and if I try to check what type it is, okay? So if I try to check the type of my tuple, we shall see that it is of a class tuple, okay? So this is also another data structure. But as we saw in lists, we can also use the tuple constructor to create a tuple, okay? So I can say this tuple, this is a variable. I've created a tuple called this tuple. So I can say tuple, okay? And double brackets, like how we saw in lists. I say apple, I can say orange, I can say maybe okay. So when I print out this tuple, just copy and paste to save time, copy paste. So okay, so have we seen what has happened? For those who love reading,
can we go back a bit? Can we go back a bit?
Yes, we are here. This is where we are.
Would you run that again?
Run this, or this?
The second one.
I'll run it. It is giving me that, okay? Now, of course, the problem here is, do you remember, guys, string formatting? I just created a typo, but I wanted you to see it, that if I just don't put this in proper quotes, of course, if I put it in proper quotes, it's going to become nice. But if I left it the way it was, without closing this string, it is going to break everything down. So make sure that you are careful when you are typing. Of course, I didn't intend it. It just happened. I just didn't intend it, but yes, those are the things that happen when you are coding, right? So make sure that you close every string properly so that you do not land in errors, and then you need to use string formatting. Okay. So now I want us to look at what tuples are. Of course, tuples are indexed. Tuples are indexed. I don't want you to forget that. We said they are ordered, okay? Meaning they follow a specific order. They are indexed, and of course, usually the first item has a 0, index 0, and the second one has index 1, 2, like that. So all the items have a specific order. That's what ordered means. They have a specific order, and that order will not change. And these tuples also allow duplicates, just like how we saw lists. So let me say my allow duplicates. And when I come to say this tuple, I can also add another apple somewhere, okay? Another apple. And when I print, copy this line, I'm appearing quicker because I'm copying and pasting. So you should also do the same. Anyway, that's what you'll be doing most of your coding. You'll be copying and pasting. So print this tuple. We can allow basically duplicated items. Okay, so now let us first try to look at what can we count items in a tuple. Count items in a tuple. We saw that we can count items in a list using which function? Who remembers? Who remembers which function we use?
Length.
We use the length, yeah? So length. I can say this tuple, okay, dot, and then open our length, and then we say, oh, no, not this tuple. I need to print. So print that, and then let's get this tuple, and the length of that tuple, and I should get 4. Okay, so we can count items within the tuple. And when you create a tuple, now this is one thing, another trick that I saw when you're trying to create a tuple with one list, with one item. So let's say maybe one item. Okay, let's say, for example, I want to create a tuple with one item. I want maybe events within that tuple, events. When you do this, I want us to run something. Let's check the type of one item. So when you check that, it is a string. This is not a tuple. But if you want to make it a tuple, just simply add a comma at the end. That is if it is one item in that tuple. Never forget that comma, or else you'll be dealing with a string. Has that sunk in? Let's continue.
Pardon?
I said that if we have a tuple, if you try to create a tuple, of course, we have seen that a tuple is defined with these these nice round brackets. But if you create an item, if you create something like this, of course, with our round brackets, it looks like a tuple. But in actual sense, when I run that cell, it is a string. So if you want to make it a tuple, just add a comma at the end, okay? And then it will become a tuple. That is if you're creating a tuple with one item in it. But if you're creating a tuple with multiple items, that is okay. You just don't need another comma at the end, okay? So let us, of course, a tuple will allow multiple data types. So I can say, for example, let me just copy back this tuple. It can take in a float. It can take in a true. A true is a boolean. Okay. It can take in an integer 56. Okay, and it will still remain. A tuple. So let me just print that out. Print out this tuple, run the cell. We see that, of course, it remains as our original tuple. So tuples also allow multiple data types. And we can access items within a tuple using indexes, okay? Accessing items within a tuple. We can use indexes too. So I can say print this tuple. Let me just copy and paste it, because we just do that and say index 0. Index 0, of course, will give me apple. Okay, so you see that we can access items within a tuple. But I want to show you that we said tuples are immutable. Let's try to maybe reassign this value apple into something like maybe orange or maybe like jackfruit that is not there in the tuple. So let's say this tuple at index of 0, we want to maybe change it to jackfruit. Okay, so have we seen that? Tuple object does not support item assignment. So once you create a tuple, the only way to add values within that tuple is through a small hack that that I'm going to show you, but you cannot assign it like this. This will only work for lists. Okay. So let me show you that the first step is to convert that tuple into a list. Okay. Step 1, convert the tuple into a list. And then what you do is you change the list by assigning that item, change the list, and then convert it back. Convert now the list into a tuple now. But you cannot do it directly like how we were doing it with lists. So step 1, let's say we have a tuple named X. Let's say it has I put my favorite car. I put maybe Jeep. I put maybe Toyota. Okay. So this is our tuple. Step 1, convert the tuple into a list. So we remember our list constructor. So I can name another tuple. Maybe let me call this as, but I can change it into a list which is named new cars, and I will use my list constructor. Okay, my list constructor, I say list, and I'll take in cars. Okay, I'll take in cars. Now, when I take in cars, I convert because now it has become a list. Okay, it has become a list. Even if we do not print it out, let's maybe say print out new cars for. It is now a list, as we can see. So convert that item on new cars at index 0. Let's maybe change it to a Bugatti. Okay.
Joshua,
yes.
On that line of new cars, and we're converting it back to what?
We're converting it to a list, yes.
Why didn't you use double
quotes? I was actually hoping.
Curl brackets.
I was actually hoping someone could ask it. So let's see if I do this. Okay. It still works. But in the instance that you are creating a list where you have items directly, okay? If you have items, like let's say I was trying to create a list with I do not need this. If I was trying to create a list with this, that is where I would have to use the double quote, the double brackets. Okay. But now I already have it saved as, it's already a variable. So I do not need that.
Okay.
We have understood. So if we already have it as a variable,
I beg your pardon, Josh. I beg your pardon.
So we said that when we are creating a list, we can create a list using a list constructor. Okay. So we say list, if we want to create a list with maybe numbers 1, 2, 3, 4, 5, 6. Okay. This would throw an error. So we would need to wrap it again in double. We need to wrap to put double double brackets, okay? But I'm saying that here, we already have cars stored as a variable, and it is a tuple, okay? So since we already have these cars, we do not need to put double brackets. But even if you put double brackets, it will not bring you an error. It is okay, it will work, okay? Yes. But even if you do not use them, if you already have it as a variable, it's okay. So now we have converted new cars into, at index 0, this Audi, we have replaced it with a Bugatti. Let me not replace my favorite car. Let me put it at position 1. Let's replace that Jeep. So now we have Bugatti replacing Jeep. So the other option now would be to convert it back into a tuple, okay? We can maybe say other cars, or we can call the initial variable and store it again with those with those values. But now I need to turn it back into a tuple and take in new cars. Are we getting it now? Now, if I print other cars, okay? If I print other cars, I would be having a tuple. That is the only way you will add an item into a tuple. But directly assigning it like how we're seeing in lists, okay? How we're seeing it in lists work is not going to work in tuples. You have to take that shortcut, okay? So now tuples are immutable, so they do not have that append method, they do not have that add method, okay? So they are immutable. So you have to try to find other ways on how to change it, to add items or remove items, and that is how we do it. So if you wanted to remove an item from a tuple, you would also have to follow the same procedure. Convert it into a list, you remove that specific item, and then convert it again into a tuple. You'll not be able to remove an item directly from a tuple, okay? So, but yes.
I was just inquiring, do you also have methods of like sorting within tuples?
Within tuples, yes, there are some methods that we can deal with in tuples, but they are not so many. They are not so many. Let me get something. Where are my tuples? Tuple methods. Let me try to get it here. Let me share it. So on W3 schools, there are only 2 inbuilt methods that you can use on tuples. That is count and that is index, because these are meant to be immutable data types. So you're not going to perform anything special on these tuples unless you use those shortcuts that I was trying to show you. Is that okay? I see it is 9:40. Sadly, I've not been able to go to sets, but let me try to show you a little bit about tuple unpacking. Or maybe I can show you, let me show you that you can actually add 2 tuples together, and let me bring in the item of tuple unpacking. So when we create a tuple, for example, cars, I've created a tuple called cars, okay? This tuple, this is what we call tuple packing. Okay, we have packed our tuple. Oh, let me just put a hash here. We have packed our tuple. Now, to unpack basically means that we want to assign values in a tuple, like for example, Audi, Jeep, and Toyota, directly into separate variables, okay? So when we create a tuple, we assign values to it, okay? And this is what I'm calling the tuple packing. Now, but we are allowed to actually extract these values. And let me say, for example, I have a tuple person, which I would have maybe to, let me say, Josh. Josh is 50 years old. It is an integer, and it is basically, let me say, is a developer. So when we have something like this, we can unpack this tuple. Since we have already packed it, now I can pack. Unpacking means this is, you see, if you follow closely, this is my name, this is my age, and this is my profession. Okay, so I can unpack it like this: that name, okay, age, maybe you can say career, is equal to person. I've assigned 3 variables to one. I've assigned 3 items to 1 variable. Now, I can print, if I print out name, and I print out age, and I print out career, you see what happens? I get the name alone, I get the age alone, I get the career alone. And this is not limited to only tuples. Even if this was, let me copy this same code, but now I name him person maybe 2. I say he is maybe now, is Gerald. Says Gerald, he's maybe 40. Is what's wrong with my 5? So I did something like that. But I name, age, career. Let me change this into a list because I no longer want to make it a tuple. And if I printed the same things here, let me just copy this code. Okay. And it will still work. Oh, wait. So person 2, it's bringing the variables that I have here. So let me say name 1, age 1, career 1. So let me print out this name 1. Let me print out age 1, and let me print out career 1. So why isn't it? Oh, I've assigned them to person, which person is already stored, yet I want person 2. Okay, so now there it changes. It gives me, but you see, it also works with the lists. I can unpack a list. Now, there are other ways to unpack tuples, but using what we call loops. Now, and loops are what we're going to introduce in the next tutorial. Okay, so let us hold on to this for today. But if you already know how to use loops, you can unpack a tuple using loops. So now, what else can I show you in tuples? They're really, really nice tuples. We can join tuples. Let's say joining tuples. I can have tuple 1, or maybe let me say this person, and have this person. Let me have person 2. Person 2. So I can have another variable called all persons, and I say I need person here, me paste, plus person 2. Okay, and I can print out this all persons. Okay, and when I print it out, oh, sorry, can only concatenate tuple, not list to a tuple. Yeah, this was a list. So You see that errors are not bad. They actually tell you what to do. I had forgotten that person 2 was actually a list, not a tuple, and I was trying to join those two. So it just told me that, you know what, it's a type error. Can only concatenate tuple, but not a list to a tuple. Okay, so you need to just learn how to read those errors, and you will be good. So yes.
Can you combine a list and a tuple also?
No. That's what was happening. That if I have this as a list, it's going to throw a type error.
Why?
Because it tells you can only concatenate a tuple to a tuple, but not a list to a tuple. It's a written rule in Python that you can't do that. So yeah, but if you had a list maybe and you wanted to join it to a tuple, you'd follow the other route of first converting it into a tuple, and then you join those two. So now when we come and look at our all persons tuple, it contains all those added tuples. And something interesting is I can actually even multiply tuples. It seems weird, but yes, I can say all persons actually. I can print out this tuple, all persons, which is down here. Okay. And I just say times 2. And it will multiply that tuple times 2. So those are just the different operations that you can do on tuples. And I believe members are tired, so let us start the class from here. And in the next session, as I had hoped that we shall start with the project and then loops. So we shall start from sets and dictionaries. Then we shall carry out our project. So do we have any questions before we close?
Yes, Josh, I have a question.
Yes.
Let's say in a real project environment, how are these tuples helpful?
So that is the first thing that I described when we were starting these data structures. We said tuples can store days of the week because we have learned that tuples are immutable. So they're important for storing that information that will not change. So for example, days of the week, months of the year, we know that they are constant. We can use it to store coordinates. If, for example, those of using self-border, so you don't need those coordinates to change, so you can store them in a tuple. We have seen that lists are changeable, and therefore you can store them in things like shopping lists or grabbing user input. I had wanted to show you something before we close. Something small about taking user input. This is something that I should have introduced at first, but I forgot. So when you want to take user input, we have a function called input. Okay, input, the input function. Okay, so this input function allows you to put information for Python to grab your user input. So for example, let me say enter name, or maybe let me say name or username. I can say username is equal to input. Okay, input, and we open up a string telling us to enter your username. So for example, you're logging into a system. Okay, and when we run it, it will tell you enter username. So it gives you a space. So let me say my username is that. So when I run, let me print out actually username so that we can see what we inserted. So if I tells me enter username, I say Joshua, and when I run that, when I run this, I just need to press an enter, and it will print out the username. Now, I want you to note that when you're inputting user, when it's grabbing user input, let me change this to age. Let me just open up let me just use another cell and say maybe user age. We want to enter our user age, and we say maybe enter age. So let me print out user age here. So I run that cell, they tell me printing your user age. I get a 15, a 45, which is my age, I enter, and then that's the age. Now, if I print out the type of user age that the user has entered, user age, okay? It is a string, despite the user having entered a number, okay? User input is stored as a string. How do we do that? How do we change? How do we change? So you remember when we talked about typecasting. So let me open this. Let me just copy it in another cell. So we can just use typecasting and say int and put that input function within the int. And when I do run that cell, I put in my real age, which is 15. And when I try to print out the type of my user age here now, I should be getting a class of integer. Now, we shall see why you might actually need to store this as an integer, because of course you're putting in an age. What if you wanted to test the system to see if the people who are not maybe below the age of 15 to access the system? You would need actually to have integers. So it is very useful for you to use that. There's also another formula that I used to use, which is another function, which is called eval. Okay, so with eval, I will also put in my age, and when I print out the user, it will show me that it is of class integer. Now, this is something that I wanted to introduce actually last week, but I think I forgot it. It skipped my mind. But grabbing user input is also a very important topic, especially next week when we're doing our project. We shall take in user input and try to perform logic on it, and we shall see how to basically proceed. So, thank you for paying attention. Thank you for being
Are you going to share the file after the class?
Let me actually share. I keep forgetting. Let me share this file. Let me save this notebook, and I'm going to share it on WhatsApp right now.
Okay.
Okay. Have a good night, guys.
Good night.
Thank you.
Good night.
Thank you.